contains various models that are being assembled together in that assembly file. So our first objective should be, that is before creating the assembly file, all the files that are going to be assembled has to be there in a single folder. Now in the last section we have seen how to select the working directory and we have created the assembly models. So here also, before you create the assembly file, first you have to set the working directory. And what will be the working directory? It is the same directory in which you have stored all your model files. So I'll go to my documents, in the project folder, assembly demo. Here I have all my model files. Let me open and show you the folder. You can see this is the assembly demo file. These are all the models that are going to be assembled, and we have to select the assembly file path as this folder. So this is the folder. Now just click on OK. After that we will select new, and this time we have to go for assembly. We have to create an assembly file and subtype will select design. We can give the assembly name. We can name this as valve assembly. Now here uncheck this use default template. Click on OK. Here during naming you have to prevent this space. Instead you can insert a character, maybe a hyphen or a underscore. Now click on OK, and we have to go for selecting a template. You can go for MMNS, millimeter Newton second, assembly design absolute. Click on OK, and our assembly file has opened. So this is how we can create a assembly file. Let us save this file. We'll go to file and save, and you can see this is our working directory and this is our assembly name. Just click on OK, and it has been saved. If you want to see it, let us open the folder. You can see valveassembly.asm is the file that we have saved now. We'll be working on this file during our entire module. So let us start importing the model files for assembly inside this file. In the next lecture, we will know how to import the model files for assembly. In this lecture, we are going to import the model files into our assembly file. This assembly file we had created in the last lecture. Here you can see various icons are there. We need not bother about all these icons. Our main icon is assemble. When you click on this assemble icon, here we have set the working directory, so it is directly opening the assembly demo folder, and in this folder you take any part and click on open. You can see we have inserted a part into our assembly file. It is very easy to insert the part, but just inserting the part doesn't mean it is complete. You have to go for something called constraining. In the next lecture, we will go for discussing the concept of degrees of freedom and constraining. In this lecture, we are going to see what is the concept of degrees of freedom and constraining. In the last lecture, we have seen how to import a model file into the assembly file. Just click on this icon, assemble, and select your model and click on OK. Now, here, this model can rotate in variety of different ways. You can see this is the display dagger that is positioned here. If you click this on, then that will be displayed. Now it is off. When you click this on, you can see this is just a widget for moving your part, so that you can move your part to your preferred location and keep it before you constrain it. Now, what is constraining? If you see here, this model is moving in variety of different ways. Each way is a degree of freedom. So, if you just remember, in sketching, I had told you what is the degrees of freedom. Degree of freedom is the direction in which an object can move. In a 3D, there are 6 degrees of freedom. If you calculate the negative, positive, clockwise, anti-clockwise, then there are 12 degrees of freedom. But forget that. Let us consider 6 degrees of freedom. 6 degrees of freedom are translation along x-axis, translation along y-axis, translation along z-axis. These are the 3. And rotation about your z-axis, rotation about your x-axis, rotation about y-axis. These are 3. So 3 translation and 3 rotational degrees of freedom. For each 3D object, you have all these degrees of freedom. These degrees of freedom, you have to constrain it by the method called constraining. Now, we have to use some constraints for this constraining. These constraints, you will get it somewhere here. You can see there are so many constraints that are available. So, we have to use these constraints and restrict the degrees of freedom of this object. Distance will give a distance between two faces, and angle offset will give an angle, and there are so many things which we have to see in action so that we can understand. We also have constraints here. You can see. So, for understanding this constraining, you have to see the things in action. So, in the next lecture, we are going to start our valve assembly. During that, we will see how the constraints are getting created and how the objects are being constrained by using various constraints. From this lecture, we are going to start the valve assembly. We are going to insert the disk file into this, and then we are going to constrain it. We had seen how to insert the first model. We'll go to assemble, click on this icon, and we are going to insert the first model into our valve assembly file. Click on disk and open it. You can see. Now, as I have already told you, it is enjoying all the degrees of freedom, and we have to constrain it. Now, for constraining this model, we have to use the references of a different model or the assembly planes. Let me cancel this. Here you can see these are the assembly planes. These are the 3 assembly planes. Now when I click on assemble, click on disk and click on open, we get some more planes which belong to the disk. Those are also getting inserted. Now where you want to keep this disk, it's up to you. But what I would suggest is, when you are inserting the first model, that time you have to go for placing it by default. When you click on default, you can see the base model has been positioned with respect to the assembly coordinate system. So you should create your base model such that it resembles your required assembly. The way you want to create the assembly, in the same orientation your base model should be there. Other models doesn't have to be in relation to anything, because we are going to assemble the other models with respect to this base model, which is the disk. So let us click on default and click on OK. You can see we have inserted our first model. Now we have not seen how the degrees of freedom have been restricted, because we have not used any constraints. The constraints have by default added to the model, and the model has been constrained. In the next video, we are going to see how the constraining process actually is done when we will insert another model into this assembly file. Now if you see here, this is the model tree that we have seen in solid modeling, but here this is the assembly model tree. You can see these are the three assembly planes, this is the assembly coordinate system, and this is the first file, that is first model that we have entered inside this assembly file. If you click here, you can see all the structure of the modeling process. So just close this. So whenever we insert a new file, it will display here. So here you can see what all files you have added onto your assembly file. Basically this is the database or structure of the assembly file. This is called the model tree or the assembly navigator. In the next lecture, let us insert the T-bolt. In the last lecture, we have seen how to insert this disk. Now, in this lecture, we are going to insert the T-bolt. Now, whichever plane you don't require, you can hide it. You can see, I'm hiding all the planes that are not required. Only 3 planes are left out. Now, out of the 3 planes, these 2 planes belong to the assembly. Let us switch this on, because we are going to use those. Here we can just click this and hide. So for the disk, we are hiding all the planes. Now let us insert the other model. Here we will go for shading with edges so that we can see all the edges and it will be more prominent, and we can have a better visual style. Now let us go to assemble. If you hover over this icon, you can see it is showing us the shortcut key, that is A. In bracket, whatever comes, it is the shortcut key. You can click on the icon, or you can also press the A key on the keyboard. I'll click here. Now I'll select T-bolt. Click on open, and here is our T-bolt. So this display dragger is switched on. That's why this gizmo is coming. When you switch it off, it disappears. Let us switch it on because I prefer rotating and keeping the part in the position where I require to assemble. You can see I have to assemble here. Just move it. It has to assemble something like this. You can approximately keep it. You need not be exact. You can see. So that I can work near the location. Also, you have an option to see only this T-bolt in a different window. Here, if you click this separate window, let me make this a bit bigger so that we can see the views. You can see. Rotating this doesn't disturb this object. And also you can select the faces and all the other features of this T-bolt for constraining in this window also. Let us see how to constrain the object. Here, instead of this automatic, I'll go for coincide. Now what I want to do? I want to coincide one of this face. Here I can select this face. You can see. With this face. You can see it has inserted. Now let us move it a bit. I'll keep it somewhere here. The next constraint that I am going to give is here you click on new constraint so that another constraint we can create. Click here. The next constraint is coincident. I can select this plane. You can see on this window also we can select this plane and we will select this plane. You can see how easy is it to position the objects. Now if you see how many constraints are left out, you have to see here it is partially constrained. So what has happened is when we have coincided this face and this face of this disk, this translation has been ceased. Also if you see the gizmo, only one direction is highlighted, which is this direction. All the other directions are in white. What this means is all the other degrees of freedom are completely neutralized. Only we are left out with translation of this bolt in this direction. So only we have to constrain the translation in this direction. So for that what we can do is we can take new constraint and here we can go for coincident. We can take a face, maybe we'll take this face. We are not able to select properly, so let us use the gizmo and move it. Now we can select this face and we'll select this face. You can see now the object is of different color, which means it has been fully constrained. Also you can see the status here, it is fully constrained. Now as soon as we click on OK, you can see the T-bolt has been positioned perfectly. Now we require the same T-bolt at 3 different places. So for doing that we can use pattern. Let's select the T-bolt in this model tree. You can see the T-bolt has been selected. Now we will click on pattern and here we'll go for axis, and axis we can select this axis. You can see it is very similar to the pattern that we have seen in solid modeling. We'll give 3 members here because we want 3 T-bolts, and the angle is 360 divided by 3, which is 120. Click somewhere to see a preview. This is what we want. Now click on OK. You can see here the T-bolt has changed to pattern of the T-bolt. Let us hide the planes. In the next lecture we are going to assemble the cover which will come above this. But now you have to save the file. You should save the file repeatedly so that there won't be any loss of data. So in the next lecture we will see how to assemble the cover onto this assembly file. In the last lecture we have inserted the T-bolt. Now in this lecture we are going to insert the cover and it is going to be positioned around this area. Let us go for assemble and we'll select the cover. Click on open. You can see the cover has inserted. Now let us move this cover to the area where actually we require it. It is somewhere here. You can see. Position it a bit above. Now as soon as you start constraining, all these colors will disappear and it will become white. So when it comes to white, then you will know that all the constraints have been given and all the degrees of freedom have been restricted. Now all the degrees of freedom are left. So we have to give it. Let us give it. So the first constraint that we are going to give is coincident. Here we have the axis of this cover. You can see. If you are not able to see here, we'll click on the separate window and here you can see very easily. We'll select this axis and we'll select the axis of this disc. You can see. As soon as I have selected the axis, many degrees of freedom have been restricted because in this gizmo, this rotation is seized, this rotation is seized, and also some directions are seized, which are this direction and this direction. We are left out with only this direction and rotation. Now let us constrain this rotation. For constraining this rotation, we'll take a new constraint and we'll go for coinciding. You can see this axis. If you are able to select here, it's fine, or you can also select here. Let us select here. Select this axis with axis of this T-bolt. You can see the rotation has been restricted. Now only this is left out. For constraining that, we'll click on new constraint and you can either coincide or you can also give a distance. Let us go for distance so that we will understand how distance works. We'll select this face and we will select this face and let us keep it at a distance. Here you can give an offset distance. Let us give some 4 mm. Click on enter and you can see you can also change this value. Maybe I'll make it 2 mm. And here you can see it is fully constrained. Now click on OK. So we have inserted the cover in our assembly file. In the next lecture we are going to insert nut. Let us save this file. In this lecture, we are going to insert the nut into our assembly file. The nut is going to be positioned above this T-bolt. Let us click on Assemble and we will select nut. Click on Open. You can see this is the nut. Here also you can see the nut is there. Let us hide this separate window so that we'll get more workspace to work on our assembly. Let us position this. I'll keep it somewhere here and maybe somewhere here so that it will be near to my location. Now the very first constraint that I'll use is coincident, and this axis of the cylinder I'm going to coincide with this. You can see. Now we'll go for new constraint and again I'll go for coinciding. You can see there are two constraints left out, which is this translation and rotation. Now this translation is going to be constraint. When I will coincide this face with face of this cover, you can see. Now only rotation is left out. For constraining the rotation, what I'll do is we'll go for new constraint and maybe we'll give parallel one of these faces. We'll take this face with maybe I'll take face of this T-bolt. You can see. Now the status is it is completely constrained. Click on OK and you can see the nut has been inserted in its perfect position. Now let us go for pattern. So before that we'll select nut from this model tree and then we'll click on pattern, and here we'll go for axis. The axis we can select this disk axis. Here we'll go for 3 numbers and we can go for 120 degrees, which is 360 divided by 3. You can see the position is perfect. Just click on OK. You can see the power of assembly module in Creo. Now let's go for save. Go to file and save. In the next lecture we are going to assemble the plate. In this video we are going to insert the plate into our main assembly file. The plate will come and assemble somewhere here in this bottom face. Now I have made a small error so that I can show you a method for correcting that error, because you may also face that kind of error in practice or while doing some projects. Let us see what is the error. Now if you see the model of the disk, here these are all blind holes and our plate will come and attach on this surface. So our plate has many holes. If you see the drawing here, this is dia 20 holes, which are going to be the assembly feature for creating this plate assembly onto the disk. But these holes will get assembled with this hole. But as this hole is not through, so it is not coming through this face. So the hole that we have made on this disk is incorrect. Let us check the drawing and then we will check the model. Here if you see the disk model, you can see here this counterboard hole is 30 into 10 and 20 into 20, and the thickness is total 30. So this is 10 plus 20, 30. This is also 30. So it should be a through hole. But why it is not through hole? Let us check where is the problem. So for activating this disk, you can click here in the model tree, just select disk, and this is the icon for activating. Click on this icon. Now all the other parts and the assembly features have been de-highlighted. Only the disk is highlighted. If you click on this arrow, it will display all the features that we have created on the disk. And if you see here, everything is de-highlighted. Only the disk is highlighted. Now let us go for creating the amendments onto the hole. You can see this hole 2 is for this counterboard. Now let us select this hole 2. You can select this hole 2 and click on this edit definition. Now let us check out where was the problem. If you click on this shape, we had given the dimensions here. Here this is 30 and this is 10. So it is correct. Next, this is 20. So 20 die is okay. Now if you come over here, this 20 is the problem, because if you see the drawing here, this is 20 into 20. That means from here to this total depth it is 20 and not this entire thing. So this is actually 30. If you click somewhere, you can see a preview. Now the hole is through. Click on OK. You can see the entire pattern has changed, and this is what we want. We can go for saving it, and then we'll close this and select this and activate to activate the entire assembly. You can see now the holes have been made through. So this is the disk that we want. Now save this file again, and remember, we have made changes on the disk here. It will take these changes and save it in your disk file. So you need not worry about modifying the original file. It will get modified automatically. Now let us assemble plate. Click on OK. You can see this is the plate. Now let us move it maybe somewhere here, and I'll move it a bit down so that I can see the object. The very first constraint is coincide. This is the axis of the plate, and this is the axis of the disk. Click and you can see many directions have been constrained. Both of these rotation have been constrained and translations have been constrained. So again I am saying, in this gizmo, the directions in which the degrees of freedom have been restricted are displayed as white and others are in color. Now let us freeze this rotation and then we'll go for translation. So click on new constraint, and here we can go for coincide again, and we will select this axis of this hole with axis of this hole. Now we are left out with only translation. So click on new constraint again and we can go for coincide again. So if you see here, I am using only coincident because it's a very powerful tool, and for creating the other things it may or may not be required depending upon your requirement. Mostly in many assemblies we use distance, angle, parallel, coincident, and sometimes tangency. So these are the things that we require in most of the assemblies. So here we can go for coincident again, and we will coincide this face with this face. You can see the status has come as fully constrained. Click on OK, and we have inserted our plate. Here you can click and you can hide all the planes. So that the view will be cleaner. See? Even if you want, you can hide this annotations. You can see we are hiding the annotation. Now it is much cleaner. Now let's insert the bolt and tighten the disc with this plate, and that we will do in the next lecture. In this video we are going to insert the bolt into our main assembly. Let us go to assemble, click on assemble, and we'll select bolt, click on open. You can see this is the bolt. Let us move it and position it somewhere, maybe here, so that we can very easily position the bolt onto this position. Now we'll go for the first constraint. Click here and we will go for coincident as usual. Click on this axis. You can see this is the axis, and we will select the axis of this hole, which is this. You can see both of them have been aligned, and we are left out with only 3 constraints, first and second. Now for restricting this rotation degree of freedom, we'll take a new constraint and we'll go for, maybe let us give angle, because we have already seen parallel. Let us give angle. Click on angle offset, and we will give an angle maybe between this face and this plane. You can see between both we can give a angle value here. This is the angle. Let us give an angle maybe some 10 degrees. You can see a 10 degree angle has been given between this face and this plane. Now we are left out with only one constraint. You can see all the other have been turned as white. Only this is left out, which is green. So we have to constrain this translation degree of freedom. Now we are left out with angle maybe some 10 degrees. You can see a 10 degree angle has been given between this. See, between both we can give a angle value here, face and this plane. You can see between both we can give a angle value here. This is the angle. Let us give an angle, maybe some 10 degrees. You can see a 10-degree angle has been given between this face and this plane. Now we are left out with only one constraint. You can see all the other have been turned as white. Only this is left out, which is green. So we have to constrain this translation degree of freedom. We'll go for new constraints, and here we can go for coincide. Instead of rotating and selecting this face, we can go for separate window, and here we can rotate and select this face very easily. And here also we can select this face. Selecting this face, we can go for separate window, and here we can rotate and select this face very easily. And here also we can select this face. You can see it has been positioned perfectly.
எதுக்கு நீ மீட்ல போடுற நீ போட்டோ எடுத்து அவர மாதிரி வாட்ஸ்அப்ல அனுப்பு
At its required position, click on OK. You see? Now the same bolt we require another 5 numbers. So we'll select bolt here, and immediately we'll go for pattern. Here we will go for axis. Axis we can select this disk axis, and the number of members we can give 6, and the angle will be 360 divided by 6. Press on the enter key to see a preview. You can see the position is perfect. Just click on OK, and you can see we have positioned all the bolts. Now for clarity we can just hide all the planes. See? This is what we want. Now we are left out with only 2 parts, which will come over here. First is the key, and second is the bush. So let us position them. First let us position the key. The key will come over here in this slot. We'll see that in the next lecture.
Before 9 o'clock, after lunching nearest before 8.
In this lecture, we will be inserting the key model into our main assembly file. The key will come and position in this slot. So let us do it. We'll go to assemble, and we'll select key in our working directory and click on open. See, this is the key. We'll rotate it and keep it in almost the same position where we require it to be assembled. See? It should be something like this. Now let us go for coincident again, and we'll coincide this face with face of this key. You can see some degrees of freedom have been restricted, so it is showing partially constrained. Now what we can do, we can go for new constraint, click on new constraint, and again we'll go for coincident. and we can coincide. I'll switch off this separate window, this cylinder with this cylinder. You can see. Now it is showing fully constrained using assumptions. So, what are assumptions? Assumptions are some constraints that the Creo software is assuming to make this body fully constrained. If you click here allow assumptions, then this will be fully constrained using assumptions. If you click it off, then it will require some constraint. If you see, this rotation is left out. So you can constrain this rotation by giving a new constraint. We can click on new constraint and we can take parallel this face with this face. You can see it has moved up. We can flip it, and then if you see here, it is fully constrained. I suggest you to not take assumptions, but if the assumptions are made and the object is placed in the perfect place, so why not? We will go for assumptions. So it is up to you to decide we are going to take assumptions or not. I have shown you both the options. You can take assumptions, or without taking assumptions also you can go for coinciding. Now just click on OK, and you can see the key is inserted. Now the same key we require on the other side. So what we can do is we'll select the key, and here we can go for mirror component. Click on mirror component and just select the plane and click on OK. You can see another component has been made this side. It's a separate component and it is mirrored. So you can see we have completed inserting the key. Now only we are left out with the bush. After inserting the bush, our assembly will be complete. In the next lecture, we will be inserting the bush. Let us save this file, and I'll meet you in the next lecture. In this lecture, we are going to insert the last part into our assembly file, which is bush. The bush is going to come and sit over this surface. Let us click on this assemble and we'll select bush. Click on open. You can see this is the bush. Let us move it and keep somewhere here. You can see. Now we'll go for coinciding this axis with axis of the bush. We are not able to see the axis because of this color, so you can click on this separate window. Here it is clearly visible. Click. You can see. Now I can switch off this separate window. Now we are left out with one rotation degree of freedom and one translation degree of freedom. The other directions will not activate because they are already constrained. Now click here, new constraint, and we will go for parallel, and we will take this plane parallel to plane of the key. You can see the rotation degree of freedom has been constrained. Now we are left out with only this translation. And this translation, what we will do is, we will give a new constraint called distance from this face, or we can give the distance from this face to this face. Here, let us give a distance of 10 and see what happens. Press on the enter key. You can see. For the other direction, you can give minus. Press on the enter key. You can see. Let it be 10 and click on OK. So we have created a completely constrained assembly. All the bodies are completely constrained. Now it is not looking good. There are so many planes and it is creating a messy environment. So if you want to select only the data, here we have this selection menu. Suppose I will select data, and if I select, I can select only data. See, I'm able to select only data, so I can make the window selection and right click here, and we can select on this height. You can see everything has been done except the part. Now it is very clean. So with this we have completed our completely assembly, which is the wall basically. To enhance the visualization, we will go for changing the colors of the model. This we will do it in the next lecture. Let us save this file, and I'll meet you in the next lecture. In the last lecture, we have completed the entire assembly. You can see. Now, all the models that we have inserted in this assembly are of the same color. So, it is quite difficult for the new viewer to understand which is a different part. So, it's better if we go for changing the colors of the objects. So, in this lecture, we will see how to change the colors of the objects. Let us start by first changing the color of this face. So, here we will go for body, and let us select the body for which we want to change the color. Let us start with this disc. Select the disc, and here in the appearances, just click here. You can select any of this color. See? Escape key, and select the body again. And maybe I'll select that green color. Select the body again. And see. There are various appearances. Let us select this body, and select this default appearance. Again we can select. We go for edit model appearance. Here we can select how we want our model to be. You can see we are applying transparency. Here you can change colors. Yes. In this lecture, we will see how to change colors of the objects. Let us start by first changing the color of this face. So here we will go for body, and let us select the body for which we want to change the color. Let us start with this. Select the this, and here appearances. Just click here. you can select any of this color. See? Okay. And select the body again. And maybe I'll select green color. Select the body again. You can see there are various appearances here. Let us select this body and we'll select default appearance. Again we'll select. We'll go for edit model appearance. Here we can select how we want our model to be. You can see we are applying transparency. Here you can change colors. So this is how you can give custom colors. See the color preview here. Which you are using. Suppose this is what I want. Click on OK. Transparency let reduce a bit. Or I will make it 0. Even. Select. We'll go for edit model appearance. Here we can select. Again we can select. We'll go for edit model appearance. Here we can select how we want our model to be. You can see we are applying transparency. Here you can change color. So this is how you can give custom color. You can see the color preview here. Which you are using. Suppose this is what I want. Click on OK. Transparency let reduce a bit. Or I will make it 0. Even texture also you can insert that by inserting some image. Let us click it off and close it. You can see. So similarly, I can select maybe this cover and here I can select green. I'll select this is not. I'll select this color. Even this nut also I'll take this color. This nut also I'll give this color. Keyboard let it be the same color. Now let's select this board and we will go for edit model appearances and click on this color. This is what I prefer. See. This is what I want. Click on OK. And close. Now same thing I want on here. Click. This also. This body. And also this board. You can see. Let us change this color to maybe this color. See the color. It's quite bright. I don't want this. Select it again. And we will go for here there is a light level. There are so many colors also. You can give some aluminum colors. There are some legacy colors. So you can select here and depending upon your requirement you can give the color. Maybe I'll take this color. It's very easy to give the color in Creo. And here we'll take this and let us take a copper color. See? And for this we'll go for some colors. See?